Good morning, one and all. This is Leena Maria S. from Government Engineering College, Calcutta. Here I am going to discuss about the third semester subject Transform Calculus, Fourier Series and Numerical Techniques with subject code 18 MAT 31 prescribed by Visheshwarya Technological University, Belgaum. We are going to see Module 5 Numerical Solution of Second Order Ordinary Differential Equation, Session 1, which helps us to understand the techniques of solving second order ordinary differential equations numerically using Runge-Kutta method. I like to convey this information through this particular contents, introduction, problems, assignment and some references. Learning outcome for this session. At the end of this session, students will be able to determine if a given system of ordinary differential equations is stiff. Solve a system of initial value problems numerically with the second order Runge-Kutta method. Let us consider y double dash is equal to g of x comma y dash with the initial conditions y of x naught is equal to y naught and y dash of x naught is equal to y naught dash with the given second order differential equation. Consider y dash is equal to dy by dx is equal to z. On differentiating this with respect to x, which gives us y double dash is equal to d square y by dx square is equal to dz by dx. The given second order differential equations assumes the form dz by dx is equal to g of x comma y z with the initial conditions y of x naught is equal to y naught and z of x naught is equal to z naught. Hence, we have two first order simultaneous ordinary differential equations. dy by dx is equal to z and dz by dx is equal to g of x comma y z with the initial conditions given y of x naught is equal to y naught and z of x naught is equal to z naught. Taking f of x comma y z is equal to z, we have the following system of equations for solving. dy by dx is equal to f of x comma y z, dz by dx is equal to g of x comma y z with the conditions y of x naught is equal to y naught and z of x naught is equal to z naught. So let us see the formula for the Runge-Kutta method. So here we use Runge-Kutta method to find the values of y of x naught plus h and z of x naught plus h. So here k1, k2, k3, k4, L1, L2, L3, L4 and h are the small increments in y, z and x respectively. So we find k1, k2, k3, k4 and substitute in the value of y. Similarly L1, L2, L3, L4 and substitute in the value of the y dash, that is we are going to find for z. So k1 formula is given as k1 is equal to h f of x naught, y naught, z naught. Similarly L1 is equal to h, we are going to see the second function, that is g of x naught, y naught, z naught. K2 equals h f of x naught plus h by 2, y naught plus k1 by 2, z naught plus L1 by 2. L2 equals h g of x naught plus h by 2, y naught plus k1 by 2, z naught plus L1 by 2. K3 equals h f of x naught plus h by 2, y naught plus k2 by 2 plus z naught plus L2 by 2. L3 equals h g of x naught plus h by 2, y naught plus k2 by 2, z naught plus L2 by 2. K4 equals h f of x naught plus h, y naught plus k3, z naught plus L3. L4 equals h g of x naught plus h, y naught plus k3, z naught plus L3. On substituting this in y of x naught plus h, that is equal to y naught is plus 1 by 6 k1 plus 2 k2 plus 2 k3 plus k4. Substituting the values of k1, k2, k3, k4, we get the value of y of x naught plus h. Similarly, y dash x naught plus h is equal to z of x naught plus h is equal to z naught plus 1 by 6 L1 plus 2 L2 plus 2 L3 plus L4. On substituting the values of L1, L2, L3, L4, we get the value of z of x naught plus h. So using this formula of Runge-Kutta method, we are going to see the problems regarding with this. First problem, given d square y by dx square minus x square dy by dx minus 2xy equals 1 with the conditions y of 0 equals 1, y dash of 0 equal to 0, evaluate y of 0.1 using Runge-Kutta method of order 4. Given d square y by dx square minus x square dy by dx minus 2xy equals 1 with the conditions, here we are going to see the conditions. Y of 0 equals 1 is nothing but y equals 1 at the value of x is 0. Y dash of 0 equals 0 is nothing but y dash value is 0 at the value of x is 0. So we get y equals 1, y dash is 0 at the value of x is 0. So now we are going to put dy by dx is equal to z. On differentiating this with respect to x, we get d square y by dx square is equal to dz by dx. So the given equation, on substituting this here on the given equation will be of the form dz by dx minus x square into z minus 2xy equals 1. Hence we have system of equations dy by dx is z and dz by dx is equal to, on shifting the terms on the right hand side, we get 1 plus 2xy plus x square z, where the conditions given are y equals 1, y dash is nothing but z is equal to 0 and x is equal to 0. So let us consider the first equation. F of x comma y comma z is equal to z. G of x comma y comma z is equal to 1 plus 2xy plus x square z with the initial condition x naught is equal to 0, y is nothing but y naught is equal to 1 and z naught is equal to 0, and let us take h is nothing but 0.1. So x naught plus h, that is nothing but x naught plus h is 0.1. X naught plus h is 0.1. Since x is what? 0. I'll get the value of h is 0.1. So now we are going to find the k1, l1, k2 and l2. k1 is equal to h f of x naught comma y naught comma z naught. So h is nothing but 0.1, f x naught is nothing but 0, y naught is 1 and z naught is nothing but 0. We are going to see the first function. F is nothing but the first function and the value of the function is nothing but, here I am going to get only the z term here. So 0.1 into z and z is nothing but here 0. 0.1 into 0 is nothing but 0. The value of k1 we get as 0. L1 is equal to 0.1 into, I am going to see the second function. The value of the second function is nothing but 1 plus 2 into x naught y naught. So x naught is nothing but 0, y naught is nothing but 1 plus again x naught square which is 0 square and z naught. Z naught also is 0. So after substituting these values and simplification, we get 0.1 and this is nothing but just 1. 0.1 into 1, I will get 0.1. So k2 equals h f of x naught plus h by 2 comma y naught plus k1 by 2 comma z1 plus l1 by 2 equals h is nothing but 0.1 f x naught plus h by 2. You have to simplify this. X naught is nothing but 0 plus h is 0.1 by 2 0 plus 0.1 by 2. On substituting this, I will be getting 0.05. 0 plus 0.1 by 2. 0.1 by 2, I will get 0.05 plus 0, which is nothing but 0.05, comma. Again y naught is 1 plus k1 value. From the previous part, we get k1 is nothing but 0. 0 by 2 is 0 plus 1, which is nothing but 1, comma. Z0 plus L1 by 2. Z0 is 0 plus 0.1 by 2. 0.1 by 2 is nothing but 0.05 plus 0, I'll get 0.05. So this is your function f, 0.005 comma 1 comma 0.005 equals 0.1 into the value of the function f is nothing but z. The value of z here is 0.005. So 0.1 into 0.05 is nothing but, after multiplying these two terms, we get 0.005. The value of k2 is equal to 0.005. L2 is nothing but 0.1 into, we are going to see the second function, 1 plus 2 into this part, that is equal to x is nothing but 0.005 into y now, that is y terms 1 plus x square 0.005 whole square into z term, which is nothing but 0.005. After simplifying and multiplying with 0.1, we get 0.11. So these are the values for K2 and L2. K3, h into f of x0 plus h by 2, comma y0 plus k2 by 2, comma z0 plus L2 by 2 equals, h is nothing but 0.1. F of, simplifying these two terms here, 0 h by 2, which is nothing but 0.05, comma 1 plus k2 by 2. K2 from the previous part, we get the values. After simplifying this and with addition with 1, we get 1.0025, comma z0 plus L2 by 2. Simplifying L2 by 2 and addition with z0, we get 0.055 equals 0.1, and this here the function with respect to f, I will get only the z term here, 0.1 into z, which is nothing but 0.055 equals 0.1 into 0.055 multiplying, we get 0.0055. So L3, 0.1 into 1 plus 2 into x, which is nothing but 0.05 into y, 1.0025 plus x square, which is 0.05 square into z, 0.055. Simplifying and multiplying with 0.1, we get 0.11004. So these are the values for K3 and L3. Similarly, K4. K4 is equal to h, f of x0 plus h, comma y0 plus k3, comma z0 plus L3 equals, h is nothing but 0.1, f of x0 plus h value is 0 plus h, that is nothing but 0.1, comma y0 plus k3, y0 value is 1 plus the previous k3 value, substituting I will be getting 1.0055, comma z0 plus L3, z0 value is nothing but 0 plus L3 value, whatever we get here, substitute with this, so I will get 0.11004. We get the function f, and the function of f value is nothing but z. So 0.1 into the value of this function is only the value of z here. So 0.11004. Multiplying these two, we get 0.011. So L4, 0.1. So I am going to see the second function again here. 1 plus 2 into x into z. 2 into what is your x here, which is nothing but 0.1. Your y is nothing but 1.005 plus x square, 0.1 square into z, 0.11004. Again simplifying and multiplying with 0.1, we get 0.12022. These are the values for K4 and L4. Substituting in the value of y of x0 plus h, we get y0 plus 1 by 6, k1 plus 2k2 plus 2k3 plus k4. So y of x naught plus h, this is nothing but 0.1 equals y naught is 1 plus 1 by 6. K1 from the formula we got 0 plus 2 into K2 is equal to 0.005 plus 2 into K3 is equal to 0.0055 plus K4 equals 0.011. Simplifying and dividing by 6 and adding with 1, we get y of 0.1 equals 1.0053. Second problem. Compute y of 0.1 given d square y by dx square equals y cube and y is equal to 10, dy by dx is equal to 5 at x is equal to 0 by Runge-Kutta method of fourth order. We have to find y of 0.1 given these are the equations here and initial conditions. Y is equal to 10 is nothing but y naught is equal to 10, dy by dx is nothing but z is equal to 5 and the initial condition x is 0 is nothing but x naught is equal to 0. So first we are going to see the substitutions here and we are going to put dy by dx is equal to z. Differentiating this with respect to x, we get d square y by dx square is equal to dz by dx. So the given equation will be of the form. So d square y by dx square can be written as dz by dx is equal to y cube. Now we have the system of equations here. First we are going to consider dy by dx is equal to z, dz by dx is equal to y cube with the conditions given. Y is 10, z equals 5, x is equal to 0. So if we are going to see the first function here, let f of x comma y comma z is equal to z. Second function is given as g of x comma y comma z is equal to y cube. Initial condition x naught is equal to 0, y naught equals 10, z naught equals 5. Let us consider h is equal to 0.1. Now we are going to find the formulas for L1, L2. The formula to find L1, K1 is equal to h f of x naught comma y naught comma z naught is equal to h is nothing but 0.1. F of x naught is nothing but 0 comma y naught is 10 comma z naught is 5 equals 0.1. The functions for f of x comma y comma z is given as z. So I can consider the value of z here, which is nothing but 5. 0.1 into 5, multiplying these two we get 0.5. K1. K1 is equal to, again we are going to see the same time, but we are going to see the second functions. 0.1 into the second function, which is y cube, and y cube is nothing but, y is nothing but 10 here. 0.1 into 10 cube equals 10 cube into 0.1, we get as 100. We get the value for K1 and L1. Similarly, K2. K2 equals h f of x naught plus h by 2, comma y naught plus K1 by 2, comma z naught plus L1 by 2 equals h is 0.1, f of x naught is 0 plus h by 2. Simplifying this, we get 0.05, comma y naught is 10 plus K1 by 2. K1 is nothing but 0.5 by 2 and addition with 10, we get 10.25, comma z naught is 5 plus L1 by 2. L1 is 100 by 2 plus 5. On simplifying, I'll get 55. So this is your function f, 0.05, 10.25, 55. So a function of f is nothing but only the z there if we consider. So 0.1 into function of f, I can consider only z here. 0.1 into 55, which is nothing but 5.5. L2, 0.1 into your second function is y cube. Y is nothing but 10.25 whole cube. Multiplying these two, I'll get 107.7. Similarly, we can find K3. K3 is equal to h f of x naught plus h by 2, comma y naught plus K2 by 2, comma z naught plus L2 by 2 equals h is nothing but 0.1, f. Simplifying these two terms, x naught plus h by 2, I'll get 0.05, comma y naught plus K2 by 2, 12.75, z naught plus L2 by 2, 58.85. Point 1, and again it is a function of f. I have to consider only the z term here. The z is nothing but 58.85. So 0.1 into 58.85, multiplying these two, I'll get 5.885. Similarly, to find L cube, 0.1 into your second function, that is nothing but y cube. Y is nothing but 12.75 whole cube equals, simplify this and multiply with 0.1, we get 207.27. So we get the value for K3 and L3. Similarly, we can find K4 and L4. K4 equals h f of x0 plus h, comma, y0 plus K3, comma, z0 plus L3 equals, h is nothing but 0.5, f of, on simplifying x0 plus h, I'll get 0.1, y0 plus K3, we get 15.885, comma, z0 plus L3, we get 212.27 equals 0.1 into your z function, which is nothing but 212.27. Multiplying these two, we get that is 21.227. So L4, 0.1 into your y cube terms, that is nothing but 15.885 whole cube. Multiplying this with this 0.1, I'll get 400.83. And substituting these values in y of x0 plus h is equal to y0 plus 1 by 6 k1 plus 2k2 plus 2k3 plus 2k4, we get y of x0 plus h is nothing but 0.1, y0 is 10, 1 by 6, substitute the value of k1, which is 0.5, plus 2 into k2 is 5.5, plus 2 into k3 is 5.885, plus k4 is equal to 21.227. On simplifying these, we get y of 0.1 equals 17.4162. So this is the value of 0.1. Given y double dash is equal, y double dash minus xy dash minus y is equal to 0. With initial conditions, y of 0 equals 1, y dash of 0 is equal to 0, compute y of 0.2 and y dash of 0.2 using fourth order Runge-Kutta method. Here we find y of 0.2 and y dash of 0.2 in this problem. That is, y of 0.2 and y dash is nothing but z of 0.2. Given conditions are y of 0 equals 1, which is nothing but y equals 1 at the value of x is 0. Y dash is equal to 0, which is nothing but z is 0 at the value of x is 0. And the given equation is nothing but y double dash is equal to x into y dash plus y. So now we are going to see this in the solution. We are going to put y dash is z. On differentiating this with respect to x, we get y double dash is equal to dz by dx. So the given equation will be of the form dz by dx is equal to, on shifting this to the right hand side, we get x into z plus y. The given conditions are y of 0 is equal to 1, z of 0 is equal to 0. Now we have the system of equations. Dy by dx is equal to z and dz by dx is equal to x into z plus y, where y equals 1, z is equal to 0 at the value of x is 0 here. Let us consider the first function f(x, y, z) is equal to z. G of x, y, z is equal to x into z plus y with initial conditions x0 is 0, y0 is 1, z0 is equal to 0, and we have the value of h is 0.2. Now we are going to find the value for k1 and l1. So k1 is nothing but h f of x0, y0, z0 equals h is nothing but 0.2. F of x0 value is nothing but 0, y0 is 1, x0 is 0. H is nothing but the first function, and the value of the first function is nothing but z. 0.2 into z, which is nothing but 0. 0.2 into 0 we get as 0. L1 equals 0.2 into your second function. The second function is nothing but x into z plus y. X is 0, z is also 0, plus y is 1. On simplifying this, we get 0.2. K2 equals h f of x naught plus h by 2, comma y naught plus k1 by 2, comma z naught plus l1 by 2 equals h is 0.2 f of x naught plus h by 2. On simplifying this, I will get 0.1, comma y naught plus k1 by 2, that is 1, comma z naught plus l1 by 2, that is we get 0.1. But again, that is the value of f function is nothing but only the z. So 0.2 into the value of z is 0.1 here. Multiplying 0.2 into 0.1, we get 0.02. L2, 0.2 into the second function x into z plus y. X is 0.1, z is also 0.1, plus y is 1. Again simplifying these two, we get 0.202. K3, hf of x naught plus h by 2, comma y naught plus k2 by 2, comma z naught plus l2 by 2 equals h is 0.2 f of. On simplifying these values, we get 0.1, comma 1.01, comma 0.101. So again the value of f is nothing but z. 0.2 into z is 0.101. Multiplying this, I will get 0.0202. So L3, 0.2 x into z, x is 0.1 into z, 0.101 plus value of y, which is 1.01. On simplifying this, we get 0.204. So finally we get the value for K1 and L4. K4 equals hf of x naught plus h, y naught plus k3, z naught plus l3 equals h is 0.2, f of x naught plus h is nothing but 0.2, comma y naught plus k3 is 1.0202, 0.204. Again simplifying this, 0.2 into z value I get 0.204. Multiplying these two, we get 0.0408. So L4, 0.2 into x into z, x is 0.2, z is 0.204 plus y, which is 1.020. Simplifying this, we get 0.2122. So finally we get the value for y of x naught plus h, which is y naught plus 1 by 6 k1 plus 2 k2 plus 2 k3 plus k4. On substituting all these values, we get the value of y of 0.2 equals 1.0202. So again, to find z of x naught plus h, that is equal to z naught plus 1 by 6 L1 plus 2 L2 plus 2 L3 plus L4. Substituting the value of z naught, L1, L2, L3 and L4, we get the value of z of 0.2, that is nothing but y dash of 0.2 as 0.204. Thus we get y of 0.2 and y dash of 0.2. So similarly, the next problem, that is obtain the value of x and dx by dt when t equals 0.1 given x satisfies the equation d square x by dt square equals t into dx by dt minus 4x and x equals 3, dx by dt equals 0 when t equals 0 initially. Use fourth order Runge-Kutta method. Here we are going to see this with respect to x and we are differentiating that is in t terms, x with t. So we are going to take the substitution, put y equals dx by dt. So observe carefully. And what are the conditions given here? X is equal to 3 given and dx by dt is nothing but y I am going to consider and t is equal to 0. So we are going to solve what? D square by dt square equals t into dx by dt minus 4x. So now we are going to put the substitution, that is putting y equals dx by dt. Differentiating this with respect to t, we get dy by dt equals d square x by dt square. So the given equation is of the form dy by dt equals t into y minus 4x with the initial condition x is 3, y is 0, t equal to 0. Now we have a system of equations. Dx by dt equals y, dy by dt equals dy minus 4x with x is equal to 0, y is equal to x is 3, y is 0, then t equal to 0. So let f of functions here t comma x comma y is equal to y, g of t comma x comma y equals ty minus 4x with the initial conditions t naught is 0, x naught is 3, y naught is equal to 0. So h is 0.1 because we have to find what? T is 0.1, f of x naught plus that is t naught plus h is what? 0.1. So h is nothing but 0.1 minus 0. I will get h is 0.1 here. So K1 formula. K1 equals h f of t naught comma x naught comma y naught. 0.1 into f of t naught is 0, x naught is 3, y naught is 0 equals 0.1 into again that is your value of this part here, that is y here. So 0.1 into 0 which is nothing but 0. L1 equals 0.1 into ty minus 4x. Ty is nothing but here is 0 and y is 3 minus 4x, that is 4x is nothing but 3 or 4 into 3 which is 12. Simplifying this we get minus 1.2. K2 equals h f of x naught plus h by 2, it is t naught plus h by 2, comma x naught plus k1 by 2, comma y naught plus l1 by 2 equals h is 0.1, f of t naught plus h by 2 on substituting we get 0.05, comma x naught plus k1 by 2 we get 3, y naught plus l1 by 2 on substituting these values I will get minus 0.6 equals 0.1 into, that is the value of y here, y is nothing but minus 0.6, multiplying these two we get minus 0.06. This is the value for K2. L2 equals 0.1 into 0.05, that is t, 0.05 into this into y which is minus 0.6 minus 4 into 3, that is 12. Simplifying this we get minus 1.203. So K3. Similarly K3 we can find h f of t naught plus h by 2, x naught plus k2 by 2, y naught plus l2 by 2 equals 0.1. F of, on simplifying these values we get 0.05, comma 2.97, comma minus 0.6015 equals 0.1. Simplifying this with respect to your y terms, 0.1 into minus 0.06015, multiplying these two we get minus 0.06015. Similarly L3 equals 0.1 into x, that is t into, that is 0.05 into y which is minus 0.6015 minus 4 times this part, that is x 2.97 equals, simplifying this we get minus 1.191. So finally K4, h f of t naught plus h, comma x naught plus t3 k3 plus, comma y naught plus L3 equals 0.1 into, simplifying this t naught plus h, x naught plus k3, y naught plus L3, we get f of 0.1, comma 2.93985, comma minus 1.191. On simplifying this, we get 0.1 into, it is your y term, minus 1.191. Multiplying these two, we get minus 0.1191. So L4 equals 0.1 into, that is t, 0.1 into y minus 1.191 minus 4 into x, which is 2.93985. Multiplying this, we get minus 1.18785. So we add x of t naught plus h equals x naught plus 1 by 6 k1 plus 2k2 plus 2k3 plus k4. Substituting the value of x naught, k1, k2, k3, k4, we get the value of x of t naught plus h is nothing but 0.1 equals 2.9401. Similarly, we can find y of t naught plus h by substituting the value of y naught, L1, L2, L3, L4 in this formula. We get y of 0.1 equals minus 1.196. So thus we get x is equal to 2.9401 and y, which is nothing but dx by dt equals minus 1.196 when t equals 0.1. So these are the values for x and dx by dt. So this completes this problem. Now we are going to see some assignments problem given here. So first one, by Runge-Kutta method, we solve d square y by dx square equals dy by dx whole square minus y square for x is equal to 0.1. Correct to 4 decimal places using the initial conditions. Y equals 1, y dash is 0, that is z is 0, and x is equal to 0. So we can solve the same similar problems by using Runge-Kutta method. Second one, use Runge-Kutta fourth order Runge-Kutta method to solve this equation. D square y by dx square equals x dy by dx plus y. Given y equals 1, dy by dx is equal to 0, when x is equal to 0. Find y and y dash, that is dy by dx at x is equal to 0.2. These are the conditions given. Y naught, that is y equals 1, which is initial condition, y naught is 1. Dy by dx, that is z naught is equal to 0, at x naught is equal to 0. You have to use the same process to solve this problem. So finally, third one, solve y double dash plus 4y equals xy. Given the condition y of 0 equals 3, y dash of 0 is equal to 0. Compute y of 0.1 using Runge-Kutta method of order 4. Again the same process, initial conditions, y naught is 3, y dash is 0, that is z is 0, at x is equal to 0. You can solve this problem by using the Runge-Kutta methods, and we can see some references here by Lewis Barrett, Advanced Engineering Mathematics, Sastre, Introductory Methods of Numerical Analysis, B.V. Raman, Higher Engineering Mathematics. We can use these references to do this problems. That is this module. Thank you.